We're on lesson 7 of chapter 3, which is the real numbers. First, we're going to classify real numbers, then we'll classify all numbers, and then we'll apply the density property to real numbers. All the real numbers that we're working with today are going to fit neatly onto this chart. And to explain this chart, I want to use this animal example over to the left. Everything in this circle, within this yellow circle, even if it's not yellow, is an animal. So dog, newt, salamander, bullfrog, cat, turtle, poison frog, these are all animals. But not all animals are amphibians. Everything within this green circle is an animal and an amphibian. So newt, salamander, poison dart frog, bullfrog, these are all amphibians. But not all amphibians are frogs. Frogs are even a special category. So poison dart frogs and bullfrogs, they're frogs, amphibians, and animals. All three. Unlike the turtle and the dog, which are just animals but not amphibians or frogs. Numbers work in the same way. We have either irrational numbers, which are non-terminating or non-repeating decimals. So the square root of 17, for example. Square root of 17 would be 4.123105, and it goes on and on. It actually goes past your calculator. Just calculator runs out of room. So it's a non-repeating, non-terminating decimal, meaning it just kind of random numbers throughout. We can't predict the next few numbers to come. So that means it's going to be irrational number. Rational numbers are all on the left side here. Everything within this box are rational numbers. But just like this animal example, not all rational numbers are integers. Not all integers are whole numbers. Not all whole numbers are natural numbers. So for example, rational numbers repeat or they terminate the decimal. So if you take 27 divided by 4, that would be 6.75. See how that terminates? It stops. Or we have 1 divided by 3, like this, 0.33333. It repeats. We can predict the net 3's are coming down the line, so that's a rational number. Not all rational numbers are integers then. We have -3, -2, -1. So these are the ones that are without decimals now. So they have -3, -2, -1, 2, 3, 0, 1. These are all integers. But not all integers are whole numbers. Whole numbers mean that there's no negatives allowed. So that's why these integers are on the outside of the whole number circle, the negative integers. But not all whole numbers are natural numbers. 0 gets excluded from this one. So natural numbers are only positive numbers without decimals. So for example, if I would say number 0, I would say that's a whole number, an integer, a rational number, not an irrational number, but it's not also a natural number. If I said -3, that would be an integer and a rational number, but not a whole number and a natural number. Moving on. It's asking us to write all the names that apply to each number. So I have the square root of 3. So let's do that. 3 square root 1.7205, so it's a non-repeating decimal. Remember what we said before? A non-repeating decimal, non-terminating decimal would be an irrational number, so it's its own category over there. So this would be irrational. Now we have -52.28. This looks like a terminating decimal, so it would be a rational number. But because it's a decimal, it's not an integer, whole number, or a natural number, so we'll just say rational number. Here we have the square root of 16 divided by 4. Well, I know the square root of 16 is 4, and I know the square root of 4 is 2. So 4 divided by 2 is 2. And 2 is a rational number because it's not a non-terminating, non-repeating decimal. It's also an integer because it doesn't have a decimal. It's also a whole number, and it's also a natural number. So it's all 4 of these on the left. So rational, integer, whole, and natural. Now we need to classify all numbers, meaning that some of these might not even be real. Let's just kind of do this again here. We have the square root of 15. Let's do that. 3.87, so we have a non-repeating decimal again, so that's going to fall into irrational number. Here we have 3 divided by 0. See this? We cannot divide by 0. We just broke that rule. So this is actually not even a real number. You can't even do this. It's imaginary. So it's actually not a real number. So you say not real. You can't divide by 0. It's impossible. Here we have the square root of 1 divided by 9. So the square root of 1 is 1, the square root of 9 is 3. So 1 divided by 3, or 1 over 3. 1 divided by 3 is 0.33333. We have a repeating decimal, right? So we'll do 0.3 with a line over it. Okay, so that's a repeating decimal, so that means it would be a rational number because rational decimals repeat or terminate. So this would be rational. So we have these all figured out. This one's rational, this one's irrational, and this one's not real. Now we need to find a number between 1 and 1/3 and 1 and 2/3. This is the density property. And the idea is whenever you need to find a number between the two numbers, you can just add them together and then just divide by 2. Here we have 1 and 1/3 and 1 and 2/3, so let's turn these into improper fractions and add them. 1 times 3 is 3, plus 1 is 4. So we have 4 over 3, plus 1 times 3 is 3, plus 2 is 5, so we have 5 over 3. Let's add these together. 4 plus 5 is 9. 9 over 3. And then we can divide this by 2. So divided by 2 over 1. Remember, when we divide, we would multiply times the reciprocal, so let's just do that. So times 1 over 2. So times 1 over 2. So it would be 9 over 2. So it would be 9 over 3 times 2 is 6. And that would give us, if we simplify, divided both by 3, it would be 3 over 2. If we're turning that into a mixed number, it would be 1 and then 1/2. If we're going to put that on the number line, it's going to be going right here, 1 and 1/2. So to recap that, we added these together, which gave us 9 over 3. Then we multiplied that times 1/2, or divide by 2, to get 3 over 2, which would be our answer.